Hello everyone, my name is Christopher Evangelides and I'm joined today by my colleague Ioannis Tsagatakis, where we will explain how we use ArcGIS Pro and the integrated notebook in our workflow to better understand vehicle emissions in the UK. But first, let's introduce ourselves.
Thank you, Christopher. So hi everyone from me as well. I'm Ioannis Tsagatakis, Principal Consultant at Ricardo with 15 years of experience in analyzing special environmental data using both desktop and server GIS applications. I'm leading a GIS team here at Ricardo, where we provide technical support and advice to governmental departments for the development of regional air quality and greenhouse gas policies.
Thanks, Yanni. So as I said, I'm Christopher Evangelides. I am a geospatial and Earth observation scientist here at Ricardo, specializing in Python, R, and SQL languages for handling big spatial datasets, as well as manipulating multispectral satellite data for various environmental applications, such as assessing post-fire regeneration dynamics.
And today we're going to provide you an overview of the methods that we use to map the UK emissions, particularly with an emphasis on the road transport sector. And today's presentation will include a briefing on the UK emissions inventory program. We will provide information on how these emissions are disaggregated spatially. Christopher will do a demonstration using ArcGIS notebooks, and in the end I will show you where you can find the emissions data. But first, let's talk a little bit about the emissions inventory program. It's called UK National Atmospheric Emissions Inventory, and it captures two types of emissions. On the left side, we see the air quality emissions, air quality pollutants. This is for the interest of the Department of Environment, Food and Rural Affairs. And on the right side is the greenhouse gases, who the Department of for Business, Energy and Industrial Strategy is responsible for. Under the framework of this inventory program, these pollutants are reported internationally and also within the UK. We produce national estimates. We produce estimates by its devolved administration, and also we provide local and regional outputs. So such as 1 kilometer resolution maps, site specific emissions, local authority statistics, and other national statistics. So my team is actually responsible for the special emission outputs, and you will see a few examples in a few minutes. So what does the inventory include? Actually, the inventory is it includes emissions from all the known sectors that that exist in the UK. This is the most important ones. On the right side, we see a map of the UK for nitrogen oxides for the calendar year 2018. And if we look a closer look to some of the sectors, here we see road transport, where the emissions across the motorways and the major roads, also within the big urban areas, is very noticeable through this map. Let's see another distribution that we produce. This is the domestic sector, and again you can see how the emissions dominate the big urban areas. rail sector, and the shipping sector, where you can see the activity that's happening across the channel, as well as activity between the UK and Ireland. But today we're going to discuss a little bit more about the road transport emissions. So over to you, Christopher.
Yes, thanks, Yanni. Important to compiling the National Atmospheric Emissions Inventory, and specifically the road transport sector emissions, is utilizing the data provided by the Department for Transport, referred to as count point lines, which in geometry are simplified straight lines from A to B containing the traffic data. So the core task with this workflow is mapping the traffic data, the underlying traffic data of these lines to the Ordnance Survey Open Road Network, which is the most representative road network in the UK. And regarding some numbers, more than 18,000 DFT lines containing the traffic data are needed to be mapped on more than 290,000 open road links. We can see here an illustration of these road links, where the open road, the more complex and most representative network, is shown in the bolder color. As Ioannis said before, is one very important sector for the emissions. And to do that, to transfer the data of traffic from the simplified straight lines to the open road network, we use some geospatial steps, which I will be demonstrating in a bit using notebooks in ArcGIS Pro.
If I may, Christopher, I think it's very important to note here that what we had to do was to assign as much as possible the traffic where the traffic starts and when the traffic ends, as the count point that you see on the map is representative for this stretch of the road. And because we have this two completely analog and well, let's say different geometries, I think what you're going to show us will indicate how we managed to get through to that problem we had.
Exactly. Yes, thanks, Yanni. And this is the final output, which is the 1 by 1 kilometer grids of the road transport sector and subsector of the major roads, showing the NOx emissions, where we can clearly see the M25 ring road of London in the map. But yes, let's dive into it and start sharing my screen for the demonstration. Okay, so here we see the ArcGIS Pro project, which is split with the map view on the left, showing the area of interest for today's demonstration, which includes London and the Heathrow Airport at the left here at the west. And on the right, we have the integrated notebook, ArcGIS Pro, for which I'll start running the scripts, the cells. So the first loads the Python environment, ensures that everything is loaded correctly, including the libraries, defining the root folder, which is now done. Then moving to setting up the file geodatabase, and then loading and clipping at the same time the open road links as well as the DFT lines for the specific area of interest of today. So we can see the open roads have been loaded, and the DFT lines have been loaded as well in green, and in a second the point sources, which include the traffic data. Okay, so let's change some colors and but yeah, let's change some colors and zoom to an example that was yeah, similar to what was shown before in the slides. So let's make the open road measure links red and the DFT lines blue so we can distinguish. And yeah, this is a good example of how we need to transfer the data from the DFT line in blue to the corresponding open road data. And as Ioannis has said before, it's important to capture the start and end point of these lines. Another more complex example of this is what's happening at the M25 by Heathrow Airport, where we can see this complex junction in red in the open road links that need to inherit the DFT traffic from the points here. Sorry, from the lines here. So when we click on the, let's zoom in and click on the DFT line here, we see it has a CP, which is unique to that line. And it is what will be used to transfer the data onto the open road link, which currently does not have an allocated count point. And in order to do that, we utilize the geometry of the DFT lines to create the Euclidean polygons based on the DFT lines, and we convert them to polygons, which this is what the current cell does. And I'll explain in a few seconds the importance of creating this polygon. Okay, perfect. So we can see here that, again, zooming into a specific area, we can see that one polygon here contains one count point, as all the remaining ones. And this is the geometry that will be used to transfer the count point to the open road links, which is, as I said before, our ultimate aim. The next cell runs, it creates the centroids of the DFT lines for the special join that follows. Okay, perfect. And then running this cell here creates, it is a special join, which creates the polygons containing the count points, which, as I said before, is used for the transfer of traffic. Running another one, creating a new open road layer. So clicking on that, we can see that yeah, a new layer has been created. However, it's important to say that not all of the open road links have been allocated a DFT count point for the traffic. So, and this is due to the complexity of the geometry. So running the next cell shows us which of these open road links are remaining to be allocated. So let's toggle them on so we can visualize them. So turn these ones off, zoom out, and yeah, let's change the colors. Let's make them bolder, making them red again to stand out. So there are 157 unallocated links from the open road network that need to be allocated account points. And to do that, we run the last cell in this notebook, a simple one-to-one join, getting the attributes of the nearest count point. So now if we toggle the previous one off and change the color of this one to stand out, let's skip the color and change the symbology, actually, the thickness, and zoom again on this, we can now see that this newly created layer has the count point allocated to it, including the breakdown of vehicles, which is in it is the annual average daily flow for we can see here all the vehicles, the cars, electric cars, taxis, buses, and so on. So by running these cells, we can create at UK level the open road data with the traffic for the annual average daily flow. So this is the demonstration of today. The question here is it perfect? By running this, by utilizing this approach, the answer is no, but it saves a lot of time. It's a core component to our process for the road transport emissions in the NAI. And yes, this integration of the notebooks and the map view on the left is really handy when working with big data to produce the emissions for the road transport sector.
Thanks, Christopher. I think the scalability of having the code and the quick results is quite important, isn't it?
Exactly.
So,
that's a very good point to add, Ioannis. Thank you.
There are some key benefits, though, isn't it?
Exactly. So yes, by having this workflow, by utilizing these tools in our workflow, we save a lot of time in allocating the traffic data to the open road layout. Of course, this minimizes the human error. For example, if we had to do some manual steps, this is out of the equation. So, and of course, a very core aspect of this is the consistency across the UK and reproducibility for future years.
Perfect. Thank you, Christopher. So the data are getting published within a web page and a customized web page. If I go very quickly on this to show you, this is the website for the National Atmospheric Emissions Inventory, where you can select the pollutant of interest, the sector that you want to see, but then you can query the data and get the information you want in a variety of ways. Worth saying that on the front, this website has ArcGIS JavaScript engine. On the back is ArcGIS Enterprise, shared with all the web mapping standards available. So just go back to the presentation. This is it from us. Thank you very much for your time. If you have any questions, please send us an email and we will get back to you.